Okay, welcome to Math 20, second class of week 7. And there was a extra helping a student office hour thing yesterday. If I go to the lecture notes, then down at the bottom, because it's the most recent, there's something that says week 7, Tuesday study session. And if you click on it, you can see the Jamboard for what I did with that student. And there we go. So the announcement isn't just that this is here, although you can certainly look at it if you also wanted to talk about fraction arithmetic more. But mostly that it didn't happen during the scheduled study session. That student was busy, so we met afterwards, later in the afternoon. And it wasn't at all a waste of an hour for me or that other student, but it would have been even better if there were other people there too, because I am sure other people could have benefited from more about fraction arithmetic. It's almost never true that there's only one person with a question, especially with that topic. So if you want extra office hours, study session times, then let me know. But the best way to do it is to tell me what topics you want to talk about in advance and say, I'm trying to catch up, or I'm looking back at old stuff, or whatever, and this is the thing I need to work on. And then I can send out an email to everyone and invite more people and say, there'll be a special thing at this day and time about adding fractions or whatever it is. And then maybe it's just you, but at least we've tried to make it so that that time spent helps more people than just one, and more people get help. So anyway, there's the announcement there. The other announcement is that the topics we did, we started justice, and we got through what a one-step equation was. Those are kind of the nice ones where you just do one thing to each side of the equation and get an answer. And we noticed that that usually was okay, but if the letter came second on one side and there was a subtraction or division, then it actually took 2 steps. So we talked about those to give you a heads up on what Math 60 will involve, but we don't really need that in Math 20. And that's kind of the hard part of this early part with the equations. So almost always I will start class by saying, what questions do you have about what we did last time? But I'm going to not do that yet. We'll save that for the end of class, because I don't want to get distracted in the 2-step equations when what we really wanted was just the 1-step ones to get into proportions and cross multiplying. And let's keep going with proportions and try and finish up these topics about scale factors and proportions. And then if we have time, we'll go back and talk about 2-step equations so that people going on to Math 60 can feel like, yes, I'm now ahead of things. So that's my plan for today. Did people have questions about homework that wasn't about the equations?
What's due? What homework is due? Do you
We
know?
had questions last time on the mad science measurement. So if no one has questions on that, this will be the very first class no one has had questions on it. And so mad science measurement will finally have a due date next class.
Are we meeting next Monday?
Yeah, next Monday. So everything up until that, all of the shape-shifting and then the mad science fractions and percentages, those have had a due date for a while now, but measurement has been lagging behind, which is fine.
Monday is Memorial Day though, correct?
Yeah, Monday's Memorial Day.
Oh, is it a holiday for us?
I have a question on number 4, 5, and 10 of the mad science measurement.
Okay, 4, 5, and 10. Let me write that down real quick. Ah, you're right, Memorial Day. So we have no class on Monday. Okay, well, if I was more alert, I would have known that was coming.
There's a lot going on right now. We'll give you a little grace.
I am tempted, although I will get in trouble if I don't check with my family, to say, well, we can just like show up and do a 10 o'clock study session instead of a noon one if you're all used to being here at 10. I doubt we will all be camping and barbecuing, partly because of the weather and partly because of other reasons.
Yeah, I'd be down for that 10 o'clock study session.
Yeah, if it's available, I'll come to it.
So, okay, let me pause the recording and mute my mic and go check with my family that I can commit to something at 10 in the morning and then come right back. So for the turn-in homework, measurement number 4, and I should write that at the top. Actually, I'm going to pause once more. So measurement will still not have a turn-in due date. And I am surprised no one has asked about number 4 before. This is just slightly different from the other things you've done before. So it asks about a mile and feet. We probably will need our conversion rate. How many feet are in a mile?
5,280.
Yeah. So you probably have some nice piece of paper in your notes with all these little conversion rates like a cheat sheet. But since I'm lecturing, I'm just going to stick that on the board so that we have it when we need it. Okay, including the end zones, a football field is 360 feet long and 160 feet wide. If I was to run 1 lap around the football field, how far would I go?
So
1,040 feet.
I'd go the 360 across the top, the 160 down the first width, another 360 across the bottom, and then another 160 up at the top. And that's 1,000 what?
1,040 feet.
Okay, so everyone happy with my perimeter?
Yes.
Okay, then what I actually run is 3 laps.
3,120 feet.
And then finally, what percentage of a mile do I run? So how much is 3,120 feet out of 5,280? How do I change a fraction into a decimal?
At the top to the bottom.
Yeah. I get about 0.59. So 59%.
I guess I got confused when I was doing it and I subtracted the 5,280 minus 3,120 and got the change. And then I did the change. I used the change to do the division and got a different number than what you got.
Yeah, that would be what percentage or mile do you still need to run if your goal was to run a mile?
Okay.
You probably got then 41, which is the complementary amount.
No, I got 2.44%. I don't know what I did, but I did it wrong. I probably made it more complicated than what it actually is.
That's usually the easy way to make the math not go well, is to make it harder.
Do you know what Math 98 is?
Do I know what Math 98 is? No, but I can look at that. Let's see what it says. There we are, math literacy. So it's the no calculus version of Math 60, it looks like. Let's go back here. Oops, here. Yes, so it's the way to skip over Math 60 and 65 and 95 to get to your other things.
I wonder why she had me do that.
So it's the non-STEM path to get to the dotted line. That's the one you had mentioned before, right, Debbie? You asked about those teachers?
Yes.
Oh,
That's the
okay.
class I'll be taking.
Have you taken 98 also?
I will be.
Are you going to do
probably
it
in
in
the
summer?
fall.
Oh, in the fall.
I'm going to do it in the fall.
Okay, well, let me stop the recording again. Okay, announcements done. We're now doing proportions and cross multiplying. This is review from what we did last time, but in case someone wasn't here, or just because it's good to do, we're going to start proportions at the beginning. So a proportion is an equation of the format ratio equals ratio. Make that a little wider so I can get it all in one line. And there was something that was interesting, but not terribly useful, where we could check if proportions were true. I should get that too. If a proportion is true, if the two sides are equal, then we say things are proportional. I don't know why we need another word. Equal is a good word, but there we are. So what's one we haven't done? Let's do 33. So I am wondering if 1.2 over 1.8 is the same as 4.99 over 7.56. In the last class, we talked a lot about these pictures I skipped over, and that when we do this multiply in an X-shaped game, what we're really doing is brute forcing common denominators, but then we're not talking about the common denominators because we had just brute forced them to make sure they were the same. So we don't need to check if they're the same. If you wanted to go back and look at that, you can. But for now, I'm just going to use that tool. So I'm going to pick one diagonal and multiply. 1.8 times 4.99. Make it a bit better. And I'm wondering if it is true that that is the same as the other diagonal. So I'll take out my calculator. 1.8 times 4.99 gives me 8.982. (1.2) times 7.56 gives me 9.072. And so my answer is no, they're not the same. An important thing we talked about that is worth repeating is that this middle line gives me lots of choices. Because this is an equal sign, or a maybe equal sign, it doesn't matter which diagonal I put on the left or the right. I happen to put kind of this diagonal on the left side, but I could have put the other diagonal on the left side and it would be fine. If things are equal, I can put either one on either side. And within each diagonal, I am multiplying two things. And it doesn't matter what order I multiply things. So if you wrote 4.99 times 1.8 and switched it, that's great. It doesn't matter. So I can pick which diagonal is on which side. And within each diagonal, I can pick which ones go on which side or the other. Everyone okay with that example review?
Yep.
Okay. So that wasn't too bad. We know how to multiply. It's also not terribly interesting because when would you ever want to do that? So here is a better problem. And maybe you can just see what's happening. That's okay. Maybe you can't just see the answer. So this might be that I have a picture that's 8 inches by 13 inches. And I want to zoom and make a poster that's 39 inches on the long side. How many inches would it be on the short side? Or it might be that I need to bring whatever, 8 kinds of snacks for every 13 hours I'm driving with my toddler. And I'm going to be driving 39 hours. How many snacks do I need? Or something like that. So this idea of changing proportions is something that actually happens in real life, as opposed to just check if a proportion is true. So we're going to do exactly the same thing. We're going to multiply the diagonals, but philosophically it's much different. We're not checking if something is true. We're going to be forcing it to be true. There's one value of y that works. So we're just going to find what it is. And due to that flexibility that I just mentioned, I always like my equations to have the same structure on the page. I always want to have the one with y on the left, and I always want y to be the first thing in my row. And that way, in the next line, when I multiply these two, what is 8 times 39? 312. It looks like this most friendly possible one-step equation of y times something else equals something else. You don't have to do that. You could put 13 times y on this side and 39 times 8 on that side, because you have those choices about where to write things and in what order. But my recommendation is to just always take the diagonal with y and put it on the left, and always have y be first. And that way, when you're looking back at the end of the term or working with a friend, then it all sort of matches and goes nicely. So how do I solve these one-step equations? I have something stuck onto y with times 13.
Divide by 13.
I'm going to divide by 13. If this was a word problem, I'd have to label it. If this was inches on a picture or snacks in a car, but there's no label because it's not a word problem. So look at what you wrote and look at what I wrote. Try and make sure as you practice these that your equal signs all line up, your letters all line up. Right? This stuff lines up. So the more organized you are, the easier it will be. Don't think of math as just something that's in your brain. A lot of it is a physical skill on the paper, and the better you do at that, the easier it is for your brain. Questions about what's on the board so far?
Yeah, what does the very bottom say?
Y equals 24. Look for the make the shared screen full screen option in Zoom, and it'll be much easier to see. Okay. So there is a name for this. And we call that cross multiplying. Let me do one other one. And point out the trickiness. Okay, someone tell me what to draw.
Because the 52 and y.
52.
52 and y. And I will write that as y times 52.
And then you're going to do the 4 times 91.
And I do 4 times 91. And if you would have done it 91 times 4, it doesn't matter. Okay. So the question is, what is cross multiplying? And there isn't a standard universally agreed upon answer. Some people, some books, some websites will say that starting with our proportion and getting all the way to the answer is cross multiplying. What LCC Math Division has agreed on is this step, doing the actual X-shaped multiplication. This is the cross multiplying. That way, if we want to talk about that step and focus on it, which happens a lot in Math 60, we have a word for it. because this is the cross multiplying step. If you say the whole problem is cross multiplying, then you don't have a good way to say this one step. Does that make sense? So just a heads up, if you search online for help with cross multiplying, then some teachers, some videos, some sites will say the whole thing is. Okay, also, well, no, I can keep that there. I'm writing more than I need to. If my job in writing steps is to let people see what I'm doing each time, then if I did this again, let me see, let's just do one more. Never hurts to do more. I'm going to write it more than one way. Okay, some people like all the steps that I just did. So let's do all those steps. We take the one with the letter. And we'll have n times 9 is 56 times 40. Whoops, colors. Okay, so far so good. That's how we did it before. Other people will say, that's writing too much. And I'm going to just keep using my, now I will actually be fancy and colorful. So some people will say, well, I like that step of the n times 9. And the 56 times 40. And some people will say, okay, so that means n times 9 is 2,240. And then they leave out the yellow step.
Hello? Okay.
And that's fine. I can still see what's happening in each step. How did we get from here to here? We must have divided by 9 on both sides. Other people will say, I don't actually need to multiply 56 times 40 and write it out. Whatever it is, I'm going to do a divided by 9 on both sides.
Yeah.
And that's fine too. I can see what happened. Over here, you did 56 times 40 divided by 9 and got your answer.
That's good. Miss you. I'm in math class right now.
So you don't need to write both of these lines. You see how in the middle we left out this line? And on the far right, we left out that line?
Tell me later. I love you.
Love you too.
Sorry.
No, you're fine.
Okay, everyone okay? Let me write this again. Okay to skip. Line number 3, or here, okay to skip. Line number 2. What you can't do is skip them both. If we had this missing, then how do we get from this to here? That's just too much to trust that someone will give you full credit for that. We're not quite sure how you got from that to that. Or if you left out this one, again, you're going right from this first line to the answer. That's too much to count as showing your steps. So I will write all of this because I am lecturing politely, but you don't have to. You can leave out one of these 2 lines on your work and everyone knows what's happening.
Even in my work, I for some reason always like draw a line and put the line underneath it, cross them out, put a line under the, instead of putting the divided sign, I put a line. Can I show you?
Let me talk about that because that's a common thing.
Okay, so that's okay? I don't need to change that?
Well, let me give you a heads up about that
Okay.
and you can decide. Let me write it over here. So your paper, without all the colors and things, might look like that, right?
Right.
Okay, so if someone was mean,
I think I had another step down and I just have like y, 8y, and then 32 times 3 is 96. So then I would have 8y equals 96, and then I would take the 8 over the 8 and cross them out, and then the 8 under the 96, and then just solve for y, which would be 12.
I come up with 12 also on this.
oh, I hit something wrong on my calculator. Okay.
A little bit. I have a couple more steps than what you have actually there, I guess.
Okay.
I don't know why I do it that way. It must be something that I learned.
Let me show you then the danger of it. So there's no problem here. Everyone can follow what I did, even if you wrote more steps. Right? On the other hand, if we had a different problem, and it was y over 1/4 is 3 over 1/8. Then if I cross multiply, I get y times 1/8 equals 3 times 1/4. So maybe I would write that as like y over 8 is 3/4. Oops, let me change it though. It will look better. Oops, if I do, let's just make that an 8. And then if I write it that way, where we put things over 8, then this confuses some people. That looks too much like a totem pole and not like a math thing. It's 3/4 divided by 8, but that messes some people up. So for this problem, if instead of the fraction bar for division, you wrote divided by, for some people, that's much easier to go. Does that make sense? So the only reason that you want to avoid fraction bar to mean what I'm doing to both sides with division is when you have fractions in it, then it can kind of mess up your eyeballs. So if you don't care, use the fraction things. No one's going to mark you wrong. It's just that every now and then it will make your life harder. Okay, now another one. I want to copy all of that. There is a shortcut you might have learned. So I'm about to divide the class into two groups. There's people who are going to go on to Math 60 and people who aren't. So take a moment, put yourself in one group or the other, right? We wanted to have this nice habit of writing out the cross multiplying step and then doing something to it. All three ways that were okay to write it, they all had write out the cross multiplying step. You can skip that. You can say that there are two numbers that are opposite each other, and we will multiply those. And then there's one number that's kind of the odd number out opposite the letter, and we will divide by that. We're going back to the other slide. At 56. I'll take the two numbers that are opposite each other, and that's what I will multiply. And I'll take the other one that's kind of by itself, opposite the letter, and divide by that. And you can see that that's what the cross multiplying does. The two numbers that are multiplied by each other then get divided by whatever we put on the letter. Everyone okay with my shortcut?
Yeah, that's the way I taught myself since Monday how to do it.
Okay, so I've divided the class into Math 60 people and not. If you are in the I am going to Math 60 camp, then I advise you don't do the shortcut. So here is why. This is the warning for Math 60 people. If it was a little bit more complicated, if instead of y over a number, it was y plus 1, then there's two ways to do things. When I do my cross multiplying step, I would get y plus 1 times 10 is 3 times 4. And I could take this in two directions. I could do what we call distributing. And apply the 10 to both sides of the equal sign. Both sides of the parentheses, I'm sorry. Or we could divide first. There's two different paths I take. And I haven't finished this problem, right? Things keep going either way. But there's this big difference of what am I doing? Am I taking this 10 and applying it to the rest of my left side? Or am I taking it and peeling it away and dealing with the right side with it? And based on the problem, sometimes this path is much easier, and other times that path is much easier. If you are using the shortcut, you are always picking this path, where you're going to multiply by the other two numbers and then divide by the odd one out. And sometimes that will work, because this will be the easy path. But on the problems where this is the easy path, you've now forced yourself down the hard path. So the moral of the story is, don't worry about understanding the Math 60 really. The moral of the story is, if you are going into Math 60, always write out that top line, the cross multiplying step. Because later, when you have options about where to go from there, you will want to be able to see all your options. If you are not going on to Math 60, then the shortcut is your friend. The fact that you're limiting your choices in the future doesn't matter, because you'll never see the kinds of problems that have those choices matter.
But isn't it good to practice, because eventually people will probably be going into Math 60?
Again, yeah, when I say if you're in the Math 60 crowd, then if there's any chance you're going to take Math 60, then skip the shortcut. Get in the good habit of writing out the cross multiplying steps. But there are a lot of people that take Math 20 and they just know they're never going to take Math 60. So they can use the shortcut. And you know, I'm just your math teacher. You can always ignore me and say, this term is tough. I'm going to use every shortcut. And if I have to work a little harder in 60, then I'll figure it out then. So that, by the way, is here. That's this warning that I am just gave you. Okay. Now we are moving on to word problems. In the textbook online, we're in 387. Both books happen to have the same 5.4 for where we are. And this will be your new favorite picture in just a moment. Oh no, I don't want that. So here are 4 different problems. And for each problem, some students have tried to write proportions. And for each problem, 2 of these are good and 2 of them are baloney. And we need to pick which ones work. So I want to speed it down just a little. The first one, Bill can drive 40 miles in an hour, so he can also drive 80 miles in 2 hours. We could write it 40 miles over 1 hour is 80 miles over 2 hours. We could try to write it 40 miles over 80 miles is 1 hour over 2 hours, and so on, right? You see all the different combinations happening. So your job is to stare at this for a couple minutes and try and figure out which 2 are good and which 2 are bad in each of the 4 problems. And then we'll talk about it and I'll take attendance. Okay, let's just talk about number 1 because I'm not sure that anyone has finished them all. Does this first proportion work?
Yes.
Yes, this one works. Does the second proportion work?
Yes.
It does. Does the third one work?
No.
No, 40 times 80 is not 1 times 2. And does the last one work?
No.
No, 80 times 2 is not 40 times 1. Should we do the second problem or do you want more time?
More time. Got it.
Okay, does the red answer work?
No.
No, 1 times 3 is a lot smaller than 12 times 36. Does the blue answer work?
Yes.
12 times 3 is 1 times 36. That works. Does the green answer work?
Yes.
Yes. Again, 12 times 3 is 1 times 36. And does the brown answer work?
No.
No.
No, 1 times 12 is not 3 times 36. So it would be nice if we didn't have to actually do the cross multiplying to see if they worked or not. So are there any patterns where you don't actually have to multiply? You can just see if it's set up right.
I saw a pattern and to see if they were set up right.
I think I saw a pattern too.
Okay, tell me what you saw.
So when I'm looking at the second one, and so it's like 1 hour to 12 tests, it's 3 hours to 36, like it just makes sense in my head, I guess. I don't really know. The next one is 12 to 36 and 1 to 3. Like I can see when I cross multiply those that like I can just see it in my head that that is right. Like if you look at the last one that's in brown, like you know that's not going to work. I don't know. I don't know how to explain. I don't know how to explain it.
Okay. That's completely normal. Is anyone able to get words for it?
I mean, I guess if you look at the fraction and you break it down, you know, if you reduce the second one, 3 to 36, it's going to reduce down to like 112.
It is, but again, we're trying not to actually do any math, only look at patterns. Because sometimes it might not be easy to do, like number 4. Okay, then I will give away the answer, which I always have to do. So this is another thing that if you haven't seen it, is just not your fault. Somebody should have taught you this years ago, so word problems were less scary. But here we go. I'm going to take the 40 miles in an hour, and I'm not only going to highlight it, I'm going to make it an arrow. It sort of has a direction, 40 miles in an hour. Does that make sense? I'm saying the miles comes first. And I'm going to take the 80 miles in 2 hours and make sure I give it the same direction. Miles is first, hours is second. When I apply that to my pictures, then the ones that work, the ones that we like, the arrows are parallel. Right? Miles per hour in one situation, miles per hour in another situation. One situation is on the left, the other situation is on the right. That's how most people like it the most. Every now and then somebody wants it where one situation is on the top, the other situation is on the bottom. That's also legitimate, but I'm not going to do that in class much because for most people, most brains, that seems less natural. It's always true that if one arrow goes down and the other arrow goes up, it's broken. And like Ghostbusters, you can't cross beams. You have to have parallel, separate arrows. So let's look at number 3, which we haven't done the math yet. So 220 for 1 pound. Or $11 for 5 pounds. I want to stay the same. If dollars is first, dollars has to stay first, right? Then I can tell that the ones that will work nicely will be the ones with parallel arrows. And again, for almost everyone, this is the one they like best because it's the one where the two situations each have their own side of the equal sign. So this is not realistic. No one is going to give you 4 different possible answers to already solved proportions and say which one is set up the right way. But we're staring at this so that when we set up proportions, we do it right. And for, again, almost everybody, what's most natural is to say one side of the situation is on one side of the equal sign, the other situation is on the other side of equal sign. Whatever label is on top has to be on top for both. Whatever label is on bottom has to be on the bottom for both. Everyone happy with the moral of the story?
Yep.
So let's actually do that a bunch. Let's start with that one. Actually, no, let's not start with that one. Let's start with that one. So when I see this kind of problem, first I notice that it's a proportion. I have a situation. I have another situation. One situation has a rate. The other situation has a rate with one number left out. There's a how many instead. So they're giving me 3 numbers. They're asking for a 4th. There's 2 situations. That's how this works. So I start reading. A car drives 45 miles on 9.3 gallons of gasoline. And at that point in the problem, I stop reading. I don't care what happens next. Whatever happens next, it needs to have miles on the top and gallons on the bottom. Otherwise, I am doing things wrong over here. So I finish writing my kind of empty proportion so that my words match. Miles on top, gallons on bottom. By the way, there might have been someone that wrote upside down. It uses 9.3 gallons every 45 miles. Don't rate this. If you did, that's fine. But as you keep going, you're also going to want to make it match. So if you put gallons on top, gallons has to stay on top. If you put miles on bottom, right? But I'm not actually interested in doing it 2 ways on this page. So at this point, we can't have messed up. Either thing could be on top as long as it matches and the same label is on top and on bottom, both sides. Okay, now I keep reading. At this rate, how many gallons, so that's the thing I don't know, are used by 121 miles? Everyone okay with my setup? Okay, now it's cross multiply time. And as we talked about extensively, I am writing more steps than you need to. I'm not going to get into that again. Oh, about 25. If you use the shortcut, because you're not going into Math 60, you could just do the 121 times 9.3 divided by 45 and get the answer that way. Everyone happy?
Mm-hmm.
So nice and reliable, unless your teacher is mean, let's watch what happens this time. Maria drinks 4 cups of coffee every 5 days. So far, so good. Again, I stop reading the problem. Whatever happens has to have cups on the top and days on the bottom. Then I keep reading. How many cups of coffee, so far so good, is this per year? What will I do?
Did you put a 12 there because it's per year?
Close.
365.
365.
365 for how many days are in the year. So the process has the priority. You know that it has to have cups on top and days on bottom. If they're not giving you days, adjust it so it's days. Everyone happy with the setup now? How we got past the evil instructor who assigned a tricky problem?
Mm-hmm.
Okay, same business as before. Did I label the last problem? Maybe I forgot. Let me check. Be right back. Nope, I put gallons. Okay. Everyone happy with this slide?
Yeah.
Okay, let's keep going. So you try and do both of these, and then I will do them once you have worked on them a little bit.
Do you just want the answers or do you want us to tell you how to do it?
I'm going to do them pretty quickly just because of time. We're at 11:24.
Okay.
Which one is the easy problem?
43 is the easiest.
I would actually say 44. When I set up 44, I have 3 problems in 11 minutes. I know I have to have problems on the other side. on the top and minutes on the other side on the bottom. So I keep reading, how long, okay, would it take him to finish a test with 20 problems? So that one was easy to set up. The other one, Susie can read 12 pages in 16 minutes. How many pages can she read in, so how many pages makes sense, but for the minutes, they didn't give me minutes.
Oh,
Right.
so you actually have to convert the 5 hours into minutes?
Yeah, 300 minutes, right?
Yeah, 300 minutes.
So 43 has an extra step.
Oh.
For some reason, my brain just processed 43 as being the easier one.
Same.
Yeah, I was in the same boat as well.
If the other step didn't bother you, then that's great. But I think sort of objectively, then an extra step makes it harder. Okay, I'll come back to this slide in just a minute, and we'll talk about scale factors when I see you next time. It's basically the same thing. For the homework problems, the random problems have one that the equation ones might be more confusing, but in the proportion things for what we talked about today, then they're not that bad. Check if something is true. So write 4 over 33, 36 over 279, cross multiply and see if it's right. Solve for a letter, and then some of them that you need to set up. Number 10 is tricky because it doesn't say what you think it says. It asks how many more. There's a subtraction step hiding at the end. So maybe you'll discover that yourself, or maybe you'll ask me on Monday or Wednesday. And then number 11 you can do, even though we haven't talked about scale factors, because it's the same kind of thing. For the turn-in homework, then there's nothing that needs to be done in the turn-in homework with just an equation, because we're built in the equations we care about into the proportion problems. So this is almost all just proportion problems. If you wanted to, you could get a good head start on the turn-in homework. So hopefully this is assuring that, yes, there are word problems. Most people don't do word problems for fun. But as far as word problems go, these aren't bad. You read the first part, figure out what one situation it is that you know about. Make sure that the labels match. See if they trick you, be careful. And then after that, it's this nice routine process. So as always, the more choices you make, the more options you have to make bad choices. A process that gives you very few choices is reliable. Any questions before we're done?
Thank you, David.
None, okay. So let's see, today is Wednesday. So Friday we'll have a study session if anyone wants that. And then Monday we'll have a class that's not a class, just for whatever you want. Oh, I do want to check before everyone disappears. Did anyone submit questions to our tutor? No. Okay, so the other way, if you're feeling behind with something, is to
We're done early today?
we're gonna, oh, I'm thinking of my Tuesday, Thursday class. No, we still have time. Let's do scaling. Did anyone share recipes? No, just me. Okay. Yeah, let's keep going because we have time.
David, can you go back to that recipes? Where
I
did
go
you
back to the recipes.
where did you put the recipe?
When you go to the Moodle class, then there's a sharing recipes thing.
Right.
So, oh, Christina did write something. So
But-
you can add your own new topic with your recipe.
Okay, I just couldn't find your recipe. Do you not list it there?
It's in the
Click there.
right
and then
there.
here
They
it
hear the
is.
recipe. Yep.
I made
Oh, okay. I didn't find the right clicking spots to go.
Okay. Yeah, I was thinking of the wrong time because I was used to class ending at 11:30 yesterday. Okay, scale factors. So we're almost done. Now we're on 5.5. If you're in the online book, still 5.4 in the Zebra book, and page 393. So some of the proportions that we solved were, as you might have noticed, just reducing or unreducing. If I can go from 40 to 1, I can multiply by 2 and get 80 over 2. Or if a parking meter costs 25 cents for 15 minutes, I can multiply by 3, top and bottom, and get 75 cents for 45 minutes. So those, we say, are scale factors. We scale up when we make something bigger with multiplying, or if we divided, we would scale down. And you don't need to notice when this happens. You can still solve those problems. So let's look at what we've done and see if there was any obvious ones. We had some earlier. So for here, we do 38 before now. So for this one, maybe we noticed that to go from 8 to 32, you multiplied by 4. So then to go from 3 to y, we'd also multiply by 4 and get 12. Or maybe you noticed on this one that to go from 4 to 52, we multiply by 13. So what times 13 is 91? That would be a 7. Or for here, maybe you noticed 13 to 39 was a times 3. So we could go 8 times 3 is 24. So scale factors refers to when you notice that there's sort of an easy way to do this going sideways to reduce or unreduce the fractions. And if you notice it, great. If you don't, that's fine too. These are just long, boring problems.
How about number 7 in the turn-in homework? That's kind of where I'm stuck at.
Okay. I don't want to, well, we can just start there. I'm not sure I want to jump all the way to 7, but sure, let's do that. And I'll make it not so wide. Okay, I don't want to give away a turn-in problem right away, so let's change one of the numbers. So instead of 120 grams, then let's say it's 250 grams. And instead of 7, then let's say it's 12. So a certain dog medicine contains 3/7 of a gram of active ingredients. For every 250 grams of dose. This was a good one because I want to put more words. If I put grams on top and bottom, that wouldn't tell me what to do on the other side. It's all grams. There's no fail-safe to keep me from setting it up wrong. But now I can say, okay, this one is going to be grams of active ingredient, and this one is going to be grams of the whole dose. Does that make sense?
Yeah.
Grams not enough, write more. And that could happen in other cases too, where you're wondering how many hours of sleep you have for hours of productivity or something like that. And they're both hours. Just keep writing words until something is distinct. Okay, for a small dog, how much active ingredient, so that's the one I don't know, do you need in a 12-gram dose? So y times 250 is going to be equal to 3/7 times 12. We also know from our other chapters, we might want to write this as 2 centigrams or 20 milligrams. That would sound a little more like how people talk about medicine. Okay, let's look at random problems a bit more.
So, just to clarify, because you changed numbers, I did the exact same thing on that one, but I'm not getting an answer that is like on there. I'm close, but like rounding wise, it wouldn't be right. Then that's where I was kind of struggling on it.
Okay, I'll double check it.
Yeah, I'll send you an email what I think the answer is before I submit it, just because I want to make sure I'm right on that. I'm pretty sure I am.
Okay. Let's do the college one, because that's a tricky one. I'm glad we have time for it. So what words am I going to have in my proportion this time?
Students and instructors.
Students and instructors. Okay, well, and what's my original situation? The one I know both numbers for.
The how many students it increases by, or like, I don't know how to word that. For that, it's gonna be 3,289 students at the top.
Not here.
Would it be the 1,541 then?
Yeah, originally what I know is they
Okay.
have 1,541 students and 67 instructors.
Okay, and then on the next one.
On the next one, then they're going to increase. And soon they will have 3,289 students, and we want to know how many instructors they'll have once they grow. Everyone okay with that?
Yes.
Now, this is the now, and this is the future. One situation on each side. But if I try this, we're not quite done. Does my color coding help when I cross multiply? Should I keep color coding?
Yes.
Yes, okay. No, it's not about equal, it really is. Okay. Okay, I'm not done. Why am I not done? It looks done.
They want to know how many more instructors need to be purchased.
Yeah, they want to know how many more. They already have the 67. This is what the search committee is asking, right? They're not in the budget committee of we have to pay for 143. They want to know how many hires do we have to make?
$76 instructors.
Everyone okay with that? So this was tricky for two reasons. One, at the end you have to subtract. And also it was purposefully worded by someone who is mean that it's not quite obvious which is the first situation and which is the second situation. Okay, holler if you want that slide back or tell me another one you want me to do.
Can we do more with fractions in the problem?
More with fractions in the problem. Do any of them have fractions in the problem? Number 2.
I always get confused with the fractions when you're multiplying and when you're dividing. And when you multiply, you just put it over 1. And when you divide it, you have to switch it so that it actually is 1 over whatever. And for some reason, I always get stumped in that. So the last problem that we did with the fraction, just literally understood where you got the 5.14. Like I was over here when you were working on the next problem, I was over here trying to figure it out. And then all of a sudden, like it clicked in my head. Oh yeah, I know how to do this. And for some reason, I just always mess up. I mix up the multiplying and dividing and switching them. And yeah, and then I was even trying to cross multiply, or not cross multiply, but like 12 times 7 plus 3. Yeah, I was just...
So remember, anytime you have a fraction, you can make it a division problem. Put it in parentheses to be safe in case that messes up something else if it wasn't. So if you're using a calculator, which you should be anyway, then just whenever you see the fraction, do that.
Okay. Well, as long as it's multiplying, but if it's dividing, you can't do that, right?
Yeah, as long as you put your parentheses around. So let's see, how about, let's change this. So what you want is something like 1/7 over 4. So you want that kind of problem.
Yeah, because I get so confused with the...
So on your calculator, you can just say 112 divided by, put it in parentheses so that we're not messing things up. Does that help?
I can't see the very bottom of the problem for some reason.
You can't see the very bottom. Okay. Then
If your little cursor is on where it says like participants and chat and stuff, you need to move it up because that little black bar at the bottom blocks it.
I don't know how to move it.
you can also make that bar hide, and if it's there all the time, then well,
Yeah.
you can. I think, can you drag it around to put it on the top, or is that only me?
Can't. But I've been so confused because I haven't been able to see the answers, but then I realized my cursor's been on that black bar where you go to chat people the whole time,
Mhm.
and where you press mute and where you start and unstop your video. So then I just moved it to the top of the screen, and now
It's
like
not letting me move it. How did you move it? Because I'm dragging.
It's just your cursor. Just move your cursor, not the black bar.
My curtain. No, that's not how it is on my laptop.
Oh.
I understand what you're saying now. Yeah, when I move my cursor, it doesn't make that go away, unfortunately. I have a slightly older laptop, so I don't know if that's why. But if you could possibly scroll down a little bit, I think I'd be able to see the bottom of it.
Yeah, I can't, but there's a thing, where is it? When you go to the settings, then in accessibility, there's always show meeting controls. And you can unclick that so they go away when you're not having your cursor on them. And the easy way to get to settings is to go to stop video. There's an arrow by stop video that says video settings when you click on it. So go into your video settings, but instead of looking at the video settings, at the bottom of the sidebar is accessibility. And then in accessibility, you can unclick where the checkbox says always show meeting controls.
It doesn't, it's not checked for me.
Not turn it, okay.
So that's unique. But I did find what you're talking about, but that box is
Not working. Okay, well, I can force it. So let's see,
You're not alone. My computer does it too.
Okay.
Sometimes I have to guess what's down there.
Yeah, it makes it really hard to follow along sometimes. I don't like interrupting other people's learning though, so I have a really hard time speaking up.
No, you need to be able to see it. The other thing you can always do is just join the Jamboard yourself in a different tab.
How do I do that?
So, and if you click where it says Jam 1, then you can see and contribute to the whiteboard even when I'm not looking at it.
Where does it say Jam 1? I'm sorry.
At the top of the main page, so go back to the main thing. And then there at the top.
I'm on that. Oh, hold on. I was looking on the wrong side. Jam 1 or Jam 2?
Yeah, Jam 1, because we haven't started a second one today yet. We're only on page 19. Oh, I can see Debbie just joined us, right? So now if I go to a different slide, anyone who's watching this can be where they want, not where I am.
Yeah, so I was checking because I still didn't solve for that 7 to 1/4 proportional to 28 is what? So that was on the slide 17.
This one?
Yeah.
Yeah.
I was just trying to figure out what it was.
Okay, well, we should go back and finish that up. So slide 19 is the same as 18. I just shrunk it so it's not to the bottom of the screen anymore. But this one we wrote and didn't finish, so.
Right.
What's 28 times 1/4?
Divided by
7.
7.
Right.
This one's gonna turn out nice.
Yeah, I second guessed myself on this one because about Isaac came out. I was like, really?
Yeah.
Now, you can, last comment before it really is time to go, you can always double check these, right? I can take one of these things and plug in, is it true that 7 over 1/4 is 28 over 1? And do your cross multiplying and say, yep, I got it right.
Mhm. Okay.
So for most Math 20 students, this is not a bad section. It might not be your favorite section, but it's nice and methodical. The calculator does lots of work. Use your tricks so that fractions aren't a problem. Whenever you see one, put it in parentheses as a division.
Okay, thank you.
You're welcome. Any other questions before we're done? I'll turn off the recordings in case people want to ask about homework.
Try and work on this more in the study session. That what time was that at on it was on Friday, right?
3:30 on Friday.